This is Austin Whitsitt. He's a flat earther. He actually got to go to the final experiment in Antarctica in December. Um, he's not a great guy. We'll find out in a few minutes here exactly how not great he is. But we'll let him ramble here for a few minutes and see what he says.
you know, Developments, information being brought to me. It's like the ether is an ocean and I'm just surfing, bro. Yeah, so discoveries, epiphanies, realizations, clarity, interpretation. You know what I mean? All right, classic topic. Could the earth be in the center of the universe? No way, are you crazy? Yo, are you staying in that place? I don't stay in place. If you don't stay in place, you either gotta go forward, you gotta go backwards, you gotta go up, you gotta go down. You know what I'm saying? It's the only way around. Up, down, forward, backwards. You gotta go somewhere. You know what I mean? Can't just stay in place. Um, so, yeah, is the Earth in the center of the universe? You know what's funny, man, is like all these people when this topic comes up, like obviously there's some OGs that come to this channel, but there are people that act like this topic is super lame. Like, why would I care? Oh, this is what, and especially when we start getting into it, like dark energy, dark matter, cosmic, the cosmological crisis. It's like, bruh, why would I care about all this nerdy stuff? It's like, well, for one, I would really encourage you to stop operating at such a low vibration. It's gonna help you out in general. Two, maybe think about the implications of the question for a second. Is the Earth in the center of the universe? Really, regardless of what you think of the universe. If you've researched it enough to realize we really don't understand it the way that the scientists claim, or you think it's just what they say it is and it's hella big. Because if you think about it, it's big regardless, right? It's just they've given us so like insane of numbers that anything smaller than that seems small by comparison. Like for those that don't know, a light year is 5.88 trillion miles. That's how far light travels in a year. Almost 6 trillion miles. 6 trillion, very close to a number that happened in the 40s and 50s. A number that happened in the 40s that you can't question. I don't question it. 6 trillion. It's 6 trillion. And if you don't look into it, you may not know that, but it's easily 6 trillion, but it's exactly 6 trillion and no more, no less.
6 trillion's nowhere near the number he's trying to hint at. He thinks that he's a Holocaust denier. So 6 trillion is close to 6 million. It's 12 orders of, it's actually not 12 orders of magnitude. A million is 6 orders of magnitude. A trillion is 12 orders of magnitude. So there's 6 orders of magnitude, or a million times off. So this is racist and kind of indicates his philosophy in life. Also, it was the 30s and 40s, not the 40s and the 50s. Okay, we're the center of the observational universe because we're observing it. That's why everything appeared to be in the center of the universe. Above is a map of the cosmic background radiation. I think it's from Kobe. This is a map of the leftover energy from the Big Bang. Gives an energy about 2.7 degrees Kelvin. And also, if you remember the old TVs that generated static, about 1 or 2% of the static on that TV was from the Big Bang. Okay, back to what's it.
So we're gonna look in our telescope out at the sky, and we're gonna see a star. Because as our telescopes get better, we start realizing, whoa, there's more stars. Whoa, there's more stars. Hey, newsflash. we still haven't seen all the stars. I had to break it to, the scriptures say, like, if you can count the stars, get at me, type of thing. It's like, you're never gonna see all the stars, bro. I hate to break it to you. Okay, we get like, because you think about it, we think we're so smooth, like through some glass and a little tube, and we can see further. And we're like, look at this, bro. Whatever's up there is like, you guys are like cavemen. Well, okay, we got some bigger tubes with glass, and we saw some more stars. And now it's for sure we've seen them all. We've seen the edge now. And they say the furthest star that we can see, okay, the furthest thing, light, that we can see in the sky, also called the universe, is, are you ready for this?
Yeah.
A light year is 6 trillion miles, 5.88 trillion to be specific. They say the furthest light we can see is 46 billion light years, bro. 46 billion light years away. So that's at least how big the universe is. Okay, so you can believe that nonsense, and we could do a whole show on how it is nonsense.
This is the Hubble Deep Field, which is a very small part of the sky, but shows a large number of galaxies. Each one of those dots is a galaxy, not a star. And the next image shows the James Webb Space Telescope Deep Field, which shows even more galaxies, and which is further away. They're about 13 billion light years away. And estimated there's about 100 billion galaxies in the universe. And you have 100 billion times 100 billion stars in each galaxy, roughly. Ours has 300 to 400 billion stars. So you get a billion is 10 to the 9, and so you get 10 to the 9 times 10 to the 9, what they add up, and you get 10 to the 18 plus the hundreds, and there are thousands in each in the galaxy, so you can get up to 10 to the 21 stars. Okay, we don't just build bigger tubes. We go into new technologies such as infrared and X-ray. Actually, to do X-ray astronomy, you have to go into space. So we have here James Webb, which is infrared, and then you have Almana, which shows the disk of stars. This is radio. This is done from the ground. Then the last image is a combination of James Webb Telescope and the Chandra X-ray telescope. To take X-ray images, you actually have to go into space because the Earth's atmosphere blocks X-rays. If they didn't, you could get cancer a lot, especially if you're out in the sun a lot. Okay, we'll go on to the next part.
But whether you believe that or you think it seems like it could be much more local, in a fluid-like medium, which would make it more dense and everything could be much closer, which is what the evidence overwhelmingly suggests.
No, the evidence points completely to the opposite. The average density of interplanetary space is like 3 to 4 particles per cubic centimeter, so it's nowhere near being a fluid dense state.
Finding out that where you live is in the center of the entire universe, because the alternative idea that we were all raised with is that it's this tiny little speck of dust. It's just this tiny little rock, this insignificant pale blue dot. Like the "you are here," it's just a little pale blue dot.
A pale blue dot is a speech from Carl Sagan. He came up with it when Voyager turned its cameras on Earth from around Neptune's orbit. It's basically to show how small and insignificant we are, and how fragile the Earth is, and how we have to depend on the Earth, and how we should not try to take over the world. Okay, I do like taking over the world in video games, but that's another story. Okay, back to its...
And it's spinning, and it's revolving around an insignificant star that we call the sun. It seems significant to us, but, all the stars are suns, actually. Even though they don't look like that, trust me, bro, they're all the sun. And the sun is actually an insignificant star, and we're just moving around it in this insignificant corner, tucked away as a little rock.
Just because something's not the center of the universe doesn't mean it does not have value. The sun is a star, and all stars are could be suns of different solar systems. And we found about 5,000 planets around other solar systems so far. Okay, some of those are just candidates and they need to be verified. But there are a lot of stars around other suns, and you can read papers about them on Archive, or if you know how, you can probably try to find some of them yourself with a large enough telescope. But it's not a trust me, bro kind of situation. Scientists verify if exoplanets are there, and they actually run computer models on if or not the stars can have faults in them that, like sunspots, that can look like planets. But we do spectroscopy, which can measure the light and determine what elements are in the sun and or stars, and determine how cool they're. The sun's actually a fairly large star in respects to most stars in the universe. It's actually, most stars are K&M stars, which are orange dwarfs or red dwarfs, and these stars are a lot more numerous. Plus, a lot of stars are binary stars, and we have found planets around binary stars. So there are planets out there. We've found them. We are a smart species.
And the rock is just randomly there. They got close enough to that star to like stick around. And then another rock hit it and broke it up into a bunch of pieces. And then one of the rocks that broke off the bigger rock stuck around. All the rest of them left. The ones that were smaller didn't stick around closer or anything. Like, that would be what you would think, right? Because supposedly gravity keeps the rocks around the rock, but based on the size of the rock, the relative size of the rocks, they stop at a certain distance away. But only one rock stuck around. The smaller ones didn't go out further and stick around. The bigger ones didn't stick around closer. Just one rock stuck around this rock, which is the Earth. And then it started spinning, because everything is spinning. And then it turned into like a perfect looking little sphere. And that's the moon. A Mars-sized body, rock, hit the Earth, broke it up, and then just one rock stuck around and turned into the moon. And by random, crazy, cosmic coincidence, where that one rock decided to stick around, the other rock, known as Earth, it just so happened to stop right where it would look like it's the same size as the sun. But it's like 400 times smaller than the sun. Just coincidentally stopped after this mystical collision exactly 400 times closer than the sun is. So they look like they're the same size. Just so happens this rock reflects light from the star that is the sun. It's insignificant but significant to us. So this physics-defying nuclear reactor in the vacuum of space that we call the sun, light reflects from it off this rock, very magical rock, mind you. We just figured that out, and it lights up. And just so happens it appears as if we have one light for the nighttime and one light for the daytime, and they're the same exact size in the sky, but they're actually not the same size. One's just an insignificant rock that came from the collisions of two other rocks and then just decided to reflect some light, and then just so happens to look like it's the same size as the sun because it's 400 times closer and 400 times smaller, creating the apparent optical illusion that they're the same size. It just so happens, that we're just insignificantly over here revolving around the one rock or the one light with the two rocks. But don't worry about it. It's random.
There's a lot of unpack here. The Earth didn't just show up next to the sun. It was made out of the same material as the sun. The sun and the Earth and the planets were formed out of a nebula that was forced to collapse. It was collapsed by either a supernova or nearby solar winds or stellar winds, or something else that forced it to collapse. And all particles have motion, and there are components to this motion. So when things collide, they tend to spin, or these things add together in weird ways called vector analysis, and these things spin. And when this nebula started spinning, it was started spinning as a sphere, but because of how gravity works and centrifugal or centrifugal forces work, the disk of material formed around the center, and in the middle there was a big ball of gas. That's where most of the material of the solar system was, of course. And in the outer regions, planets eventually formed. And near us, there was a Mars-like planet that happened to form, and it did collide into Earth. We sent astronauts to the moon, and they found that the rocks on the Earth and rocks on the moon have similar composition, so they're related. Plus, we've done computer models, and there's going to be a computer model up above that will show what that looked like. This is from NASA, and and they spend years writing these kind of codes to get this kind of detail. And I may show a bit of my own code when I tried to make a planet forming program, but it wasn't nowhere as close. It was. I ran into a few issues, so I kind of dropped it. So this is what scientists do. They come up with a theory. They find evidence for the theory through spectroscopy or through lab evidence or out in the field, and they run computer models. This is how astronomy works. It's not just sitting in your den philosophizing about science. Okay, I think that's my main points. We actually see planets being formed around other stars. These are from ALMA, the Atacama Large Millimeter Array Telescope, which is a radio telescope located in the Atacama Desert in Chile. These, you can see that there's these rings in the material, and that's where the planets are being formed because they're absorbing all the material. And also, in one image, you can actually see the planet being formed, or the little tiny dot, as the light is being reflected off of it. So we do have evidence of planets being formed.
Unrelated and unnecessary for this rock to be inhabitable. So really doesn't make sense for them to all stack on top of each other. For them to all stack on top of each other, you would think that something is like tuning it to do that, creating merely an optical illusion of the sun and the moon would be the same size, by the way, right? Which is an example. It's called a fine-tuning argument, meaning there has to be a fine-tuner for all those to stack up. So this is in fairy tale land. This is in fairy tale 6 trillion, times 46 billion miles away land, okay? Even in that world, you need a fine-tuner. But we can skip all of this, and we can go to this question that the stream is titled, could the Earth be in the center of the universe?
Okay, the reason why the sun and the moon look like they're at the same size, the moon took a lot of time to get to where it is in orbit. When it was in orbit, it was a lot closer to the Earth, and it only took about 10 hours to orbit around the Earth. So after 4.5 billion years, the orbit has slowed down, and the rotation around its axis has slowed down. So it always faces us, and it takes about 28 days for it to rotate around its axis and for around to go around the Earth. And we just happen to live in the right time to view this. What he's talking about, the fine-tuning principle? I think he's talking about the anthropic principle. There's two ways to see it. There's the strong anthropic principle, which means the entire universe was designed for us to live in, and it has nothing really much to do with the Earth-Moon system. It has more to do with the constants of atomic nuclei and I think the fine structure constant. And the weak anthropic principle just means that we just happen to live in the universe that we can live in, and there could be multiple universes or multiple situations that life could be in. Okay, I think we'll let them go for now.
Universe. And though that is considered laughable and primitive and insane, according to those that are very ignorant of all of these subjects. If the answer to the question is yes, very simple follow-up would be how to get there. How to get there, bro. How to get in the center of everything. And the obvious answer is it was placed there by something. Duh. Okay? So they don't even try to pull out the coincidence card on the Earth is in the center. It's just so overwhelmingly obvious that if it was in the center of the entire universe, it was placed there. So what did they do? They said it's not in the center, bro. Okay. Why does all the evidence say it looks like it's in the center? Well, option A is that it's in the center. Option B is whatever you can come up with to say it's just an illusion that makes us look like we're in the center, a stubbornly persistent illusion, to quote Stephen Hawking. Now, we've done lots of streams on this channel about this. I have a stream from a few years ago. It's probably been 3 years now, called Geocentrism.
It appears we're in the center because we've only been able to take measurements from where we are. If we could go to a different solar system, we'd probably see things slightly different, or a different galaxy, we'd see something different. But we only have measurements from the Earth. That's why it appears they're in the center. And for some reason, they like picking on famous scientists such as Stephen Hawking or Neil deGrasse Tyson, because they think those are the only scientists that do the work, or they're the only ones that they see in public. But okay, I think I'm gonna call it quits. This is a 2-hour stream that he did. I'm gonna call it quits for now. I may go back and do it later, but we have a little comedy commercial from another channel. I'm gonna show it. The name of the channel you may not like, but it's a good commercial. So everybody have a good after you watch the commercial, have a good day and good night or wherever you are, and see you later.
Tired of your handcrafted word salads getting mistaken for delirious nonsense? Do your conspiratorial pronouncements regarding complex scientific topics lack oomph? Yearn for the days when your pronouncements on the scientific ramifications of any subject are met with rapturous applause, not bewildered stares? Well, you're in luck. There is no better way to complete a beautiful bed of word salad, consisting of scientific terms arranged in a misleading and completely incoherent string of consciousness, topped with vine-ripened cherry-picked quotations and personal incredulity croutons, than with a rich, creamy dressing by Hubris Valley Ranch. Likewise, Hubris Valley Ranch can also be used to accentuate the flavor of a 30-minute monologue, spent exalting your intelligence and subject matter expertise in any and all scientific fields, regardless of real-world expertise. Our patented formula contains 40% more unfounded assertions per tablespoon than leading competitors, plus added electrolytes for those marathon basement research sessions. Be sure to try our new varieties, each formulated with our patented Question Everything technology, our signature pattern recognition seasoning, our new confirmation bias-free variety for the selectively skeptical, our best-selling do-your-own-research variety, perfect for those who've already done theirs on YouTube, TikTok, or whatever social media echo chamber validates them today. Now we have released our limited edition Connect the Dots blend, because sometimes the most obvious explanation is exactly what they want you to think. The more you use, the more expert you'll become in fields you've never studied. We guarantee instant confidence in all scientific debates, or your intellectual humility back. Hubris Valley Ranch is readily available in the condiment aisle of your local supermarket or favorite grocer. Hubris Valley Ranch, dress your delusions.